this is how the its profile looks like. So then we can make some assumption here, like for us to calculate the differences between the power consumption of reaction wheel and the power consumption of control moment gyroscope. So first, we assume that the moment of inertia of the reaction wheel is in this ratio of the total moment of inertia of the satellite, and also the satellite is in a shape of a cube, like we suggested in the previous slides, and also is in a 550 kilometer SSO orbit, and also we also make some other assumption here, and so we can see this is the result. This is the additional power consumption for the reaction wheel compared to control moment gyroscope. In order to solve the existing problem of the traditional CMG and then how this technology looks like. So, as mentioned earlier in the previous section, the traditional single gimbal CMG, they have actually two motors. So one motor for the inner rotor, that's the spinning disc. Another motor for gimbal, so that's something we call gimbal motor. But this additional motor makes the angular momentum to mass ratio of the traditional single gimbal CMG to be worse than the traditional reaction wheels. So we are developing a technology that is based on this spherical motor. So later on, we'll try to activate this model on the table to demonstrate how these single gimbal CMG drive by spherical motor works. Okay, so this is how our single gimbal CMG looks like. So inside there are still one gimbal as the traditional single gimbal CMG has, and inside the gimbal there is a rotor spinning. So that's the same compared to a traditional single gimbal CMG. Yeah. So the first question is actually very insightful. That is also a problem that we are currently solving. Yeah, because when the satellite is launching, the CMG has to be powered off. So that we have to prevent the rotor keep knocking the stator. Otherwise, the stator will be sabotaged. So now what we develop is to use several solenoid, so several supporting stick there. So it is there are springs there. So when the CMG is powered off, these springs they will support the rotor when during launch, and then when it's going into space, then we apply electrical current to those solenoid and let it leave the rotor, then let the rotor to be supported by a magnetic field. That's the current strategy that we are developing. But I think this might not be the only way. There might be other ways to solve this issue. But that's currently the way that